So this is the notes for sine rule, or law of sines as it's sometimes called, section 2.1. This is going to be really important that you pause your video because there's going to be a lot of writing and you want to make sure you get good notes here, good examples. So we are talking about oblique triangles, which if you look here, there's no right angles. So basically you have some obtuse, some acute, doesn't matter, but there's no right angle. So we can't use our normal trig rules like sine, cosine, tangent by themselves, and we can't use Pythagorean theorem. So the sine rule is basically a proportion. So our proportion here is A over the sine A, B over the sine B, C over the sine C. Angles down here are with the sine or the reciprocal of that. You would have both of these in your formula sheet. I usually use the first one. You can use either one. The key is how you label your triangle. So there's angle A and there's side A. There's angle C or side C and angle C. So the little letter opposite the big letter separates the sides and the angles. And you must have an angle side pair to be able to do that. And you'll see that in these examples. Okay, so example one here, given this picture, they're telling us a triangle, they're telling us a side, telling us another side, and they're telling us an angle. We're going to find an angle. It says give your answer to 3 sig figs. So you make a picture, and QRS is the name of your triangle, and just make sure everything's labeled right. Now, what I'm going to do is change some of these labels here. It says QR is 15, but really I'm calling that side S. And it says that SR is 6.5. Well, that's really little q. And then this would be little r. So if you're writing your sine rule, it would be S over sine of S. So 15 over the sine of 125 equals Q, which is 6.5 over the sine of Q equals R, which we don't know, over the sine of R. So as long as I have an angle side pair, which I have right here, an angle on the side across from it, I can use the sine rule. So I have a proportion, and I fill in everything that I know. And if you remember basic proportions when you're younger, something like this, and you cross multiply to solve. So this would be 10x equals 21. And so x equals 21 divided by 10. So when we go to solve here, that's all we're going to be doing. 6.5 times the sine of 125 divided by 15. So this is all just in one step. You can do it in 2 steps. Definitely use your calculator. And this is going to be really important in this video that you actually push the buttons on your calculator and verify your answers to make sure that they work. So we get 20.8 in this case. So if you're not getting those numbers, check your mode, make sure it's in degrees. Okay, here's just some basic examples. The picture's already drawn for us. Just get a chance to practice a little bit. So if you notice here, there's this little abbreviations. When you have an angle, a side, and an angle, or 2 angles and a side, and then sometimes side angle. That first time we did side angle, there's some special cases there. Because if you know two angles, you know the third angle. And so you'll always end up having an angle side pair. Okay, so this first problem is they're giving us 2 angles and a side. So right away, I know this other angle is 75 because all my angles have to add up to 180. And then I can work from there. So B over the sine of 62, so B over sine of B equals 24 over the sine of 43. This is key. We have our angle side pair that's given to us. So I'm going to cross multiply and divide. So this was 24 sine 62 divided by sine of 43. That's what it looks like in your calculator. So you get 31.1. Okay, and then we can set it up again. We're going to use this fraction again, 24 over the sine of 43. And we already used the b over 62, so now we'll use c over the sine of 75. And we'll get the same type of calculation. So 24 times the sine of 75 divided by the sine of 43 is 34. Second one, they give us two angles. We have an angle side pair. That's the key right there. We know 23 and we know 73, so we can use that. We can use the sine rule. That's what you always ask yourself. Can I use the sine rule? And so we can find our third angle by subtracting. Sorry, I'm writing with the stylus, not very good. So those have to have to 180. And now I can write my proportions. So 23 over the sine of 73 equals A over the sine of 58 equals C over the sine of 49. And you can solve that, and you can solve these two setting equal to each other. So go ahead and pause and see if you can solve it. Set up your two proportions. So that's A is 20.4, and that's C, 18.2. This last one, you'll notice there's two sides given and an angle in between, and so you're like, well, I don't have the angle side pair, but you took geometry and you remember that you have isosceles triangles. If you notice that the base angles are congruent, so if I say 180 minus 84, that leaves me with 96. I would have each of these being 48. They're shared. So now I do have an angle side pair. So 18 over the sine of 48 equals B over the sine of 84. One of the most common mistakes, and you be careful to do this, is to not write the sine button down there. People forget to write sine. So if you want to go ahead and solve that, you should get 24.1. So pause and solve and make sure you can do it. Okay, so this one says find the unknown angle. We're given a basic triangle, and so in our basic triangle, we're going to label things that they tell us. So A is 12.5, B is 15.4, and angle B is 68. So I have an angle side pair. So 15.4 over the sine of 68 equals 12.5 over the sine of A. And when you go to solve this on your calculator, remember we're finding an angle. So I'm going to cross multiply first. Again, you should be pushing the buttons on your calculator or your Wabbit, whatever it is. So 12.5 times the sine of 68 divided by 15.4. And it's something like 0.75258 dot dot dot. I'm going to do second sine or inverse sine of that number. And on your calculator, you can go second sine, and then there's a little thing called ands that stores the last answer. It's right above the negative sign. And you should get 48.8 degrees. Okay, so it says find the unknown angle. It says find angle A. So we got our 48.8 degrees. You could also find angle C really easily now that you have two angles to check there. Find the unknown angle. So A is 7.2, C is 5.1, and A is 70. Okay, so 7.2 over the sine of 70 equals 5.1 over the sine of C, and we don't have anything for our third. And so this says find angle C, so we should be good to go. So I'm going to write it in one step. Sine of C is 5.1 times the sine of 70 divided by 7.2. You can do that middle step if you want to. You have a calculator, save yourself a little trouble. Just be careful with fractions. So what I get when I punch that in my calculator is like 0.6656 with some stuff. So I need to do second sine. This is key. 41.7 degrees, 3 sig figs. There's another video on the assignment that goes along with the worksheet and has some practice on that. I think it's number 6 that does the practice. The last thing here is making sure you make an accurate drawing. This is one where they don't give us a triangle number 2, so I just quickly sketch an A, a B, a C, and then get my labels on here. So AC is 8. Angle C is 101. You can see my pictures already, not to scale, but it doesn't matter. Angle B is 32. And so I can find the other sides. I know that right now because I have an angle side pair. So 8 over the sine of 32 equals little a over the sine of angle A equals little c over the sine of 101. Okay, and you can find angle A by subtracting 180 minus 32 minus 101. So it's 133. That leaves us 47 degrees for angle C. So I could change that even to 47. So now I have enough proportions to solve everything. I'll let you can solve that. Cross multiply. Again, the key is if you're finding an angle at the end, you got to push second. The last one is it has to do with bearings. I just want to talk about this because there's a lot of times you get in applications of physics and engineering and such. And so there's a boat sailing due north, so it's sailing along here like this. And at a specific point in time, it sees a lighthouse 12 kilometers away. It says on a bearing of 36 degrees. That means this angle right here is 36. Bearings are always done clockwise from the north-south line because you can always find where north is. So that's 12 kilometers. And the lighthouse is right here. Okay, then the boat keeps sailing along. And at another point, it has a bearing of 125. So again, that means it's coming down here like this. And so that 125 degree is right there, looking at the lighthouse. So that means inside the triangle is actually 55. And you're not going to do a whole bunch like this. This is a helpful way to see the application, though. I know there's GPS now. There's common lingo that you learn if you're a pilot or if you're commercial, or even if you have a boat and you don't want to get lost on the ocean to understand what bearings are, even if you do have a GPS. And so I want to show you how to set this up because now we can find how far that we traveled because we don't really have an odometer out there to tell us that. So 12 over the sine of 55 equals how far we traveled over the sine of, now I need to find my angle right here. Well, 180 minus 55 minus 36. 55 and 36 is 91, so that leaves us with 89. So I can cross multiply 12 times the sine of 89, hit enter. Divided by the sine of 55. So 14.6 kilometers. So in between those 2 points. One thing that occasionally comes up as you go more in depth here, we don't do it as much in this course, is when you're given a side, and an angle, there is potential for two different triangles based on the angle and the given information. So the reason why is this side could be like that, or this side could shift over here, and you still would have the same two sides and that angle. It's called, you can figure why. If you're given a side, and angle, it's called the donkey rule. You don't have to worry about like spotting to see whether that's going to be here. It's just something to be aware of. If you want to look at it, if you're interested in it, it's called the ambiguous case, and there's some more information there if you want to see. Just download the PowerPoint if that's some of you're interested in some of that different theory, but we're not going to try to scare anybody with it. So on Canvas, the worksheet that's there, it's not your homework, but problem 6, you should practice now to see if you can do it by yourself, because it's nice because there's a video that works through that, and then we will work through a lot more examples. Make sure you're good at this. That's all we have.